Welcome, boys and girls. This is our calculus AB lecture on area. Between curves. This is lecture number 1. I'm doing this on Wednesday, the 25th, which is our snow day. Again, I thought we would be here for this. I know we're not going to be here on Thursday and Friday because of the big storm coming. So it is now your responsibility on these days to review this material, watch the material, do the homework exercises. So when we get together on Monday, we'll be up to speed. I'm referencing your class page. Go to the class page and you'll see on the right-hand sideline over here the timeline. Okay, so somewhere here is our revised timeline post-snow. I put this together last week, and again, you should just note that we are sitting here on this day, Wednesday the 25th, and this is the area material. So, yeah, we do need to cover this when we get back on Monday. We're going to be doing volume for a couple of days, and then a quick review, and we will test this prior to the end of the quarter. So areas today, tomorrow, Friday, volumes Monday, Tuesday, Wednesday, test on 8-1 and 8-2. That will be the last major grade for the quarter, and so you want to do well on that. While I've got the class page here, I'm going to reference, by the way, this, again, this is your class page. Right, so in the right-hand sidebar over here, there is this link to course descriptions. That's not what I wanted. I'll find it again, the class page. We want the link to, sorry. Don't particularly want this. Okay, well, what I'm hoping to pull up is these guys. These are the free response questions, which is also linked on your home page. So when you go over to the right-hand sidebar, you'll see free response question. This is 98. Notice the very first question was an area question. Here was 99. So not the first question, that was a motion question, but the second question was an area question. And it seemed like almost every year for 8 or 10 or 12 years in a row, the first or second question on the AP test was an area question. Okay, so here we are back in area. And what we want to do is we want to try to talk about finding the area bounded by two curves. So it's in your textbook. This is Chapter 8, Lesson 1, and some of you are going to sit there and go, well, I didn't bring my textbook home. I scanned in Chapter 8, Sections 1 and 2, areas and volumes. And so I'm looking in your text on page 462 to 466, and the exercises. Now, in point of fact, this first video, I'm just going to do example 1, and then I'll pull a problem out of the exercises, and then we'll look at a free response question. So that's the idea for today. Tomorrow's video, we'll do a little bit more. We may do example 2 and some other exercises and some other area problems from the free response question. Okay, so here's the idea. Looking in your text, if you have a function f and a function g, and you have particular values on the x-axis, say a and b, then the area bounded by f and g, and on the left and right by the lines x is equal to a, right? This would be x is equal to a, this vertical line, and x is equal to b, this vertical line. That area is given as a definite integral. So we're going to integrate from x is equal to a, that's the left-hand boundary, if you will, out to x is equal to b, upper and lower limits of integration. Probably better think of it as left and right. And the integrand is going to be the distance between f and g. So this vertical distance in here. And your textbook calls it as f of x take away g of x. So figure out that difference and then integrate with respect to x. Okay, so pretty easy. The first example shows this pretty clearly. So let me scroll down here. First example on page 464 in your text says find the area bounded above by y is equal to x plus 6. That's just a line, obviously, x plus 6. And below by y equals x squared, that's a parabola. And you should have no trouble graphing either one of those. On the left, by x is equal to 0, that's a vertical line. And on the right, by x is equal to 2. And these are obviously vertical lines. Okay, vertical lines. And a sketch is given. I would hope that you wouldn't particularly need to have the sketch given. These are pretty simple curves. The first one is a line with a y-intercept 1, 2, 3, 4, 5, 6, right? And a slope of 1. So y is equal to x plus 6. The vertical lines are x is equal to 0, which is the y-axis, and x is equal to 2, which is a vertical line right here. And so it doesn't take a lot to say this has got to be 2 comma 8, right? Here's our line. Now the bottom of this is going to be our parabola. We don't care about the entire parabola. We want the parabola that goes through these points right here. Okay, so this is the origin. There's 1, 1. This is the ordered pair, 2 comma 4. And the region is bounded above by the line, below by the parabola, on the left by x is equal to 0, and on the right by x is equal to 2. And the idea is to find the area of this region. Okay, so we just go to the definition and we say the area is going to be defined as an integral. We're going to be integrating from 0 to 2. These are the left and right bounds of integration. These are the vertical lines, 0 to 2. Okay, and then the integrand is going to be the top curve, which is x plus 6. And then you're going to subtract off the bottom curve, which is x squared. Find that difference and then integrate with respect to x. Okay, so there's the setup. And I've put some extra parentheses in here that we don't really need at this stage. But let's go ahead and finish this out. So we're integrating from 0 to 2. And we have x plus 6 minus x squared dx. So the fundamental theorem allows us to get the antiderivative pretty easily. Antiderivative of x is x squared over 2 using the power rule. The antiderivative of 6 is 6x using x as our variable. And the antiderivative of x squared is x cubed over 3. Add 1, divide by the new power. We'll put brackets there, 0 to 2, right? And then to actually get the area, we're going to have to do the parentheses minus the parentheses. And in the first parentheses, you put the 2, so that's 2 squared over 2 plus 6 times 2 minus 2 cubed over 3. And in the second set of parentheses, you're putting the 0. So 0 squared over 2 plus 6 times 0 minus 0 cubed over 3. And we clean that up as best we can. So what do we have? This is 2 plus 12 minus 8 thirds. And notice that all of this conveniently is 0. Okay, so there's our answer. And I suppose we could, what's this, 14, take away 8 thirds. So 14 is 40. 2 thirds, take away 8 thirds is 33. 34 thirds. By the way, this arithmetic is not something that you necessarily have to do, especially come May. On the AP test, oftentimes these area problems are calculator interactive. And if that's the case, then once you set up the integral, so let's think about where we set up the integral. Once we set this up, this is called the setup, you can get the answer on your calculator. Remember, calculators work definite integrals very nicely. So I have my calculator. I'm going to do math 9. That's my numerical integrator. And I'm going to be putting in the integrand, which was x plus 6 in parentheses, subtracting off the x squared in parentheses, right? So there's my integrand. My variable of integration is x, and the lower limit, the left-hand bound, if you will, was 0, and the right-hand bound was 2. And we just let the calculator churn that out, and sure enough, there we are, 34 thirds. Okay, so remember, calculators do arithmetic. Getting from the setup to the answer, yeah, you should practice that. There are some free response problems that don't allow a calculator, and certainly the exercises in the text are designed for you to practice the fundamental theorem. You know, you need the antiderivative, you need to put the upper and lower limits in to get the area. But frankly, when we go in May, a lot of times once you set it up, you're effectively done with the problem. Okay, vertical lines. Okay, so that's example 1 out of the text. And I'm going to go to the exercises, and I'm going to do exercise 2. I would like you to do exercise 1. This is on page 467. 467, exercise number 2. It has a picture given to us nicely. So we have the square root curve, y is equal to the square root of x. And we have the line, which is y is equal to minus 1/4 x. And they meet at the origin. And then we have a vertical line at 4. 1, 2, 3, 4. So we have this right here. And the task is to find the area of the region bounded above by the square root curve, bounded below by the line, y equals minus 1/4 x, on the left side by 0, right? This is x is 0. And on the right side by x is equal to 4. X is equal to 4. And again, the task is to find the area of this region. So using the terminology from the definition, this is our f function, right? That's the one on top. And this is our g function. That's the one on the bottom. So we just go ahead and write down the integral. The area is an integral x running from 0. That's the left-hand side. The right-hand side is 4, right? 0 to 4. That's these. And then the integrand is the top function, which is the square root of x. Take away the bottom function, which is minus 1/4 x. And we're going to find that difference and then integrate with respect to x. And if the question was simply to set it up, we're done. We have done the integral that gives us the area. And if we needed a number and say we had our calculator permitted, we could at this stage simply dump in math 9. The integrand is the square root of x. I'm putting this in parentheses. I know I don't have to. Minus parentheses the negative 1/4 x. And then that's my integrand, right? My variable of integration is x, running from 0 to 4. And let the calculator churn it out. And something's not right. I know that's not 117. Where did I go wrong? I got the square root. Okay, so I see what I did. I threw an extra set of parentheses in there. I wanted to get delete. Okay, so I have the square root of x minus a negative 1/4 x, lost out a division sign there. Okay, so that looks good, entered it in. And now it still doesn't like it because of what? Let's see, I've got my negative 1/4 minus a negative, I'm going to start over again. Math 9, this is the garbage in, garbage out. So I have root x. I'm just going to write plus 1/4 x, right? Comma, x, comma, 0, comma, 4. Okay, so now that makes sense. It appears to be 7 1/3. So this appears to be, just looking at my calculator, 7.33. Repeating, notice there are some digits way at the end, which are probably a result of the program not giving us exactly the right answer. That's what my calculator says. Let's go ahead and do it by hand. The author actually wants you to work these problems by hand. So we've done the setup. Now we have to use our fundamental theorem to find the antiderivative. We'll plug in the numbers 4 and 0. We should get the answer pretty quickly. Okay, so let's see. Our area is going to be the integral from 0 to 4. I have x to the 1/2, and this is plus 1/4 x. That's my integrand. So here's my antiderivative. Let's see, x to the 3/2, right, divided by 3/2, and then plus 1/4 x squared over 2. Antiderivative between 0 and 4. Clean these up a little bit. There's not much I can do with the front half. This bottom half, or this back half, is x squared over 8. So let's see. Parentheses minus parentheses. First parentheses, I've got 2 times 4 to the 3/2 over 3 plus 16 over 8, right? Because 4 squared is 16 and 4 times 2 is 8. And the back half, I have 2 times 0 to the 3/2 over 3, that's 0, plus 0 squared over 8, that's also 0. Working with polynomials and generally with algebraic functions, 0 is a nice number to work with because the second back half often reduces to 0. So what do we have here? This is the square root of 4, which is 2, 2 cubed, which is 8, 2 times 8, which is 16 thirds, plus 2. Okay, so 16 thirds plus 6 thirds, which is 22 thirds. Okay, and again, if we looked at the calculator, wherever my little calculator there is, 22 thirds, sure enough, 7 1/3. Okay, so there's an example out of the book, one of the exercises out of the book. And the last one I want to do on this first lecture is to look at this first free response question, 1998. This was one of the questions on the AP test. It was the very first one you encountered. In 1998, for this particular problem, it says a graphing calculator is required for some problems. So that tells us that the calculator is permitted. In fact, this first bit, find the area of the region, you probably don't need a calculator, but since it is permitted, we're going to use the calculator to find the area. So look at the problem first. It says the region is bounded by the x-axis. I'm going to go ahead and draw a sketch of this in just a second. X-axis, the graph y equals the square root of x, and the line x is equal to 4. This is pretty similar to the one that we just did out of the textbook. And the task is to find the area of region R. Okay, new screen. We have the x-axis, y is the square root of x, the vertical line x is equal to 4. Here's my x-axis down here. And our task is to simply find the area of this region. Okay, so here we are. The left limit is again 0 and the right limit is 4. This meets over here at 0. This is 4 here. Okay, the top curve is the square root of x. The bottom curve is this line, right? And this line happens to be y is equal to 0, so we're going to subtract off 0. So that gives us our integrand, and we're integrating with respect to x. Once we're done, we could actually go to the calculator and get the answer. So let's just pull up the calculator and clear all this off. Math 9. We have the square root of x, comma, x, comma, 0, comma, 4, bang. Okay, so 5 and a third, 5.333. Notice the decimal approximation is okay as long as you're accurate to the nearest thousandth. And even though there was some error here, the error is way back 10, 100,000, 10,000, 100,000 millionth, 10 millionths. So we're off by a couple of 10 millionths on the calculator. This is fine. If you did it by hand, let's say you didn't have your calculator, you show up for exam day and your calculator dies, and oh my God, I can't get the answer straight. It's not too difficult to do this by hand. It should go fairly quickly. We're integrating 0 to 4, x to the 1/2 dx. So we have 2/3 x to the 3/2 evaluated between 0 and 4. Remember, you don't have to do the arithmetic. Once you write down the answer, you should be okay. So 2/3, this would be 4 to the 3/2 minus 0. And if you left it like that, you would get full credit. And frankly, that may even be quicker than pushing the buttons on the calculator. Okay, so that's part A of this particular problem. We've done the area of the region. I want to look at part B, which is another area problem. So part B says, let's see, find the value h such that the vertical line x equals h divides region R into two regions of equal area. And again, there's no picture given. So let's see, here was our picture. Now you have to imagine a vertical line h. So here's the vertical line, and you're going to try to move this around such that it cuts the region into two equal areas. Well, let's suppose this is 2 right here. I would think it's pretty obvious that if the line were at 2, this is not two equal areas. The left half is much smaller than the right half. So we know that h has got to be some number bigger than 2. The question is, where is h? So this is now our line, x is equal to h. And we want to figure out, find h, such that the area on the left is exactly the same as the area on the right. Okay, so how might we go about doing these? Well, we know the total area is 5.33. 5.33. So we said that was 5 1/3, or if you want, 16/3. That was our total area there. We want this line to give us exactly half. So we want 15/6 here, and we want 15/6 here. Right, half of 15, oh, sorry, not 15/6, I can't even see what I've got there. Half of 16/3 is 8/3. So we want 8/3 here, and we want 8/3 here. That's the idea. And the task is, what is the value h? Okay, so obviously a sort of a higher order thinking question here. Working from what we already know, when we integrate from 0 to an x value, right, we're supposed to get 8/3. The only question is, we don't know what h is. Right? So when we integrate from 0 to h, going all the way out to there, we're supposed, and here's the top, which is the square root curve, the bottom is still 0. That's supposed to give us 8/3. Okay, so this equation now should be sufficient to solve for h. Now here the calculator doesn't do us any good. So we're going to have to actually get the antiderivative, 2/3 x to the 3/2, evaluated between 0 and h is supposed to be 8/3, right, using the fundamental theorem. And on the left side of the equal sign, we have parentheses minus parentheses. still have 8/3 over here. So we have 2/3 h to the 3/2. This is again 0, which just goes out. So we have 2/3 h to the 3/2 is equal to 8/3. And now this is an algebra equation that should be able to solve pretty easily. We do have to solve it, right? We have to get h equals. So multiply both sides by 3, and we have 2h to the 3/2 is equal to 8. Divide both sides by 2, so h to the 3/2 is 4. And then treat this as a power equation. Raise both sides to the 2/3 power, right? So we're going to raise this to the 2/3, and we're going to raise this to the 2/3. So that gives us h to the 1 is 4 to the 2/3. And you could actually stop right there. That would be fine. We don't have to simplify once we get 4 to the 2/3. If you wanted to write it as a radical, this is the cube root of 4 squared. Or if you want, the cube root of 16. Okay, so any one of those would be fine. If you wanted a decimal, you could. You don't need a decimal. Just to sort of see where that plays out, it might be interesting if we were to integrate. So I'm going to integrate, this time not 0 to 4, but 0 to 4 raised to the 2/3 power, which is what we said. Okay, we should get exactly half of our previous answer, and we do. Okay, so 2.6 repeating, right? 2 2/3 or 8/3. So we've got the right answer. Okay, enough for this particular lesson. Let me give you some problems to work on. I would like to, out of the textbook, I would like you to work problems 1, these are on page 467. Work problem 1, work problem 5A, work problem 7. And those 3 answers in the back. And then out of the response questions, let's see what I would like you to do. Let's see if I can find your class page here somewhere. Yes, I've been listening to country music. Go ahead, laugh. Let's see, AB Calc. Here we are. Downloads, all release free response questions and their solutions. By the way, this zip file, hopefully you can open it, but it has all the questions and their solutions, so you could actually go in and look at the solutions. We looked at 98. 99 we're going to do on tomorrow. Let's look at 2000. 2000 questions. Again, there's going to be an area problem here. Okay, so there we are. This is a nice one to do. So try 2000. 2000, the free response questions. Question number 1. And what can you do? You can certainly do part A. Okay, so again, we're going to be doing areas for 3 days, and then on Monday, Tuesday, Wednesday, when we get back, we're going to do the volume questions. So don't worry about volume now. Let's just work area. And if you just look at it carefully, you notice that it says these are the graphs. The top one is the exponential going that way. The bottom one is the cosine, right? 1 minus cosine is this guy. And we're trying to find the area of R. This is obviously 0, right? X is equal to 0. That's the left side. The right side, be cautious. This is not 1. 1 is a little bit to the right. We're going to have to figure out what that number is. You're going to need your calculator to do that, to find this point of intersection, because that's the right-hand limit of integration. So obviously you do need a calculator for here. There's your top curve, there's your bottom curve, put those in parentheses, find the difference, and then integrate with respect to x, running from 0 to whatever number this is, and find that on your calculator, and then check your answer to see whether or not you get the right area. Okay, happy snow days. Lecture number 2 coming up for tomorrow. Let me go ahead and stop this guy right here. Oops, stop this guy right here. Thank you. Thank you.